This one's going to be a pretty short integral test problem here. So we want to use the integral test to determine whether this series converges or diverges. So we're going to look at its corresponding function. So f of x is equal to x over x to the fourth plus 2x squared plus 1. This is certainly positive and continuous on 1 to infinity, so that part of the integral test is satisfied. Then we're going to go ahead and look at the first derivative to show that this is negative on 1 to infinity, so that we have the decreasing, okay? And so this is fairly routine. So if you've watched the previous examples, this one's pretty nice compared to some of the other examples here. So fairly routine in terms of checking that the derivative is negative, and it's actually going to be negative probably sooner than 1, but this is fine. But that's what we need it for, is 1 to infinity. So we're going to go ahead and we're going to look at the integral, and the integral is not too bad either. So you know, you may think about completing the square, but the denominator is already a perfect square, so we'll just factor that, and it's a nice u substitution. So u will be x squared plus 1, du will be 2x dx, and so what we'll be looking at is we'll have to divide by 1/2, and then we're going to have 1 over u squared du, so that'll be 1/2. We'll add 1 to the exponent and then divide it by the exponent of -1, so there's the negative, and then u plus constant of integration, and so right there you'll have your x squared plus 1. So I'm not going to show all of that steps here. We're going to try to fit this on one slide. So move all that, okay. And so we're going to go ahead and take the limit negative 2 negative 1 over 2 x squared plus 1, evaluated from 1 to b. We'll go ahead and evaluate our limits, and then we'll go ahead and take the limit. So the first part's going to go to 0, so this is going to converge. So the improper integral converges, so ultimately the series that we have over there is also going to converge. So we have convergence by the integral test.